So for this problem, we're going to find dy by dx when sine x cos y is equal to 3. Now, two things we've got to recognise for here. We've got sine x times cos y, so if it's time it's a product, we're going to need to use the product rule. But because we've got a mixture of variables, sine x and cos y, we also need to use implicit differentiation there, so we're going to use a mixture of the two rules. So we need to label up our usual parts. We have our u, which is sine x. So differentiate that with respect to x, nice and easy. It's cos x. Then we have our v, which is cos y. We need to differentiate that with respect to x. So first differentiate it with respect to y, which is minus sine y, and then times that by dy by dx. And once we've got that, then we can put our parts in here to differentiate this then. So using our product rule, we have our v, so therefore cos y times our u dashed, which is cos x, plus we have our u, which is sine x, times our v dashed, which is minus sine y dy by dx. Moving on a little bit further, moving to the right, we've got a constant, so when we differentiate that with respect to x, that just gets us 0. So let's simplify this a little bit then. We have cos x cos y minus sine x sine y times dy by dx is equal to 0. And we want to make dy by dx the subject. Well, let's move this to get rid of the minus. So we can say that sine x sine y times dy by dx is equal to cos x cos y. Well, if we're times here, we can move it to a division. So therefore, dy by dx is equal to cos x cos y over sine x sine y. And you might be able to spot that there's a couple of identities here. Cos x over sine x is the same as cot x, and cos y over sine y is the same as cot y. So ultimately, our expression for dy by dx when sine x cos y is equal to 3 is dy by dx is equal to cot x cot y.